Vibration Toolbox is an interface for solving single degree of freedom systems under damped conditions. I'm using Google Colab here, but you can execute these commands in terminal. To install Vibration Toolbox, run pip install vibration _ toolbox. Press Shift plus Enter key to execute the cell, or use the play button on top left. Let's import some modules. Import matplotlib. Yep. Import vibration toolbox dot vibration toolbox as VTB. I'm just using the convention written in docs. Okay. Yep, it's not working because I am using a nested module name. It's not correct. It's just vibration toolbox. Now it's gonna work. Import numpy as np for array manipulation. To get frequency ratio versus a plot, use vtb.steady_state_response and provide zeta values. All the other values will be assumed. So zs, which is basically zeta, 0.1 and 0.2. Let's do it for 2 now. Provide rmin value. So rmin is going to be 0 and rmax around 3, maybe 2.5. Run the cell to get plot. It's expecting int. To correct that, you just need to provide it rmax value in terms of int. Let's make it 2. Yep. Yeah, so it gives us normalized amplitude versus frequency ratio graph for zeta equal 0.1 and 0.2. This is frequency ratio versus lag plot. This plot is a little blurry because of the default DPI values provided by matplotlib. So let's change it. To do that, we need to change RC parameters of matplotlib. So matplotlib.rc params equal yeah, so we need to change the figure size. Let's make it 10 by 10. This is in inches right here. So if we run it and then run the same code again, the quality is going to be a little better. Yeah. Now let's use a bunch of zeta values. That's why we imported numpy. Make it zetas, and in some other cell provide zeta values. So zeta equal numpy dot linear space from 0.1 to, we don't want it to be 0 because that will create infinities in our plot and we don't want that. 0.1 to 3, and then maybe 50 or 40 values. Yep, let's make it 34. Run the cell, print zetas as well. Now run the plot. Okay, it was not expecting a numpy array, it's expecting a list. Convert our array to list. That seems more like it. Now, yeah, so for all 34 zeta values we get the plot. As zeta sort of increases, the frequency ratio is flat. almost as if there was nothing. Okay. Let's look at another way of plotting this. We plotted the previous plot with only zeta values, right? But we can also plot it with other system parameters such as m values. So let's do that. VTB dot rotating unbalanced, and then provide m value and m naught, initial value of m 0.2. I'm providing these values based off documentations. E equal 0.1, yeah. And then provide a few zetas. Let's use the default. And then our min and our max value 0 and 2, maybe 3.9, yeah. If we run it, we get the same zeta plot but for different values of m. It's basically the same as earlier plot, but here we are substituting m naught and e value as well. By default, the amplitude is normalized. To turn off normalization, just uh, turn the normalize flag to false. Now the values aren't normalized